Imagine closing your eyes and drifting into a time before time itself, a place where silence held everything, yet nothing had been born. The beginning of the universe is not just a scientific story, it is also a kind of gentle poem written into the fabric of existence. Tonight, we will walk slowly through those first steps of creation, not as hurried students of science, but as dreamers listening to the ancient whispers of the cosmos. Every fact is like a small candle in the dark, lighting up mysteries older than galaxies. As you listen, feel the wonder settle softly around you. The mystery of a beginning. Long before humans asked questions, the universe already carried its secret of how it all began. It is almost strange to think that the vast stars above you tonight were once compressed into something so small it could fit into less than a single point. Scientists call this the singularity, but to the imagination it feels like the breath being held before the first note of a song. The mystery lies in how something could emerge from what feels like nothing at all. When we talk about beginnings, our minds often look for familiar signs: a sunrise, a first breath, the opening of a flower. But the beginning of the universe did not follow any rhythm we know. There was no stage, no curtain, no sky to reveal. Only an unfolding that we still try to measure, one that left echoes across billions of years. Those echoes still touch us, faint but undeniable. The mystery deepens when we realize we cannot step outside the story to look at it. We are inside it, woven into the very fabric that was stretched in that first instant. That means the beginning is not just a tale of science, but also our own family history. If the cosmos had never opened, we would never have come to ask these questions. Even the most advanced telescopes only show us shadows of what happened. We cannot see the first spark directly, but we feel it in the glow that still surrounds everything, the aftertaste of creation, the residue of the first light. The fact that it lingers, silently humming, reminds us that mysteries can live quietly alongside answers. Perhaps that is why the beginning always feels so humbling. The more we uncover, the more we realize there is an even larger silence around it. And inside that silence, something waits, not to be solved, but to be listened to, gently, like the sound of your own heartbeat in the dark. A universe hidden in silence. Before any light, before any particle, there was silence deeper than anything we know. This silence was not the absence of sound in a room, but the absence of sound itself. Imagine lying in a space where even the idea of noise has not yet been invented. That was the cradle of the universe. What makes this silence haunting is that it carried all possibilities. Inside it, there were no stars, no galaxies, no time. Yet hidden in this nothingness was the potential for everything, like a blank canvas that already holds the promise of every painting. This was the womb of creation waiting for its first stir. Scientists describe it with mathematics, but in simple words, it was a pause, an eternal pause before the first step. To us, silence often feels empty, but here it was full of energy waiting to be released, full of futures waiting to be lived. Even in its stillness, the silence was pregnant with power. We rarely think of silence as an active force. Yet in this story, silence was not the end, but the beginning. It allowed something new to emerge, like seeds hidden under frozen soil, waiting for spring. Without that vast stillness, the unfolding would have had no place to begin. And maybe that is why silence still soothes us today. When you lie in bed and the world grows quiet, you are hearing a faint echo of that same universal hush. A reminder that even in stillness, great beginnings are quietly preparing themselves. the first question humans ever asked. Long after the first stars formed, humans looked up and wondered, where did all this come from? That question, what is the beginning, might be the oldest curiosity in our minds. Before we understood fire, before we wrote stories, we were already pointing at the stars. This question is not just scientific, it is emotional, almost spiritual. When we ask about the beginning, we are also asking about our own place in it. Why are we here, in this particular moment of the cosmic story, and not in some other? The mystery of beginnings carries us along like a tide we cannot escape. Different cultures answered in different ways. Some imagined gods shaping the heavens, others told tales of cosmic eggs or serpents stretching across the sky. These myths were not mistakes. They were attempts to hold the immensity in words the heart could understand. In every version, the stars were seen as family, as ancestors shining above. Science came later with its instruments and equations, yet in many ways the question remained the same. What was the first moment, and what was before it? Each discovery only opened the door to another layer, never closing the question entirely. Perhaps that is why, even now, lying beneath the night sky can stir something in us. The stars remind us of a question too vast to ever be fully answered. And maybe that is the beauty of it, that the asking itself connects us to the beginning. Darkness before light existed. It is hard to imagine a world without light. Every day begins for us with the rising of the sun. Every night is still softened by the glow of the moon or stars. But before the universe gave birth to its first light, there was only darkness, a kind of pure, endless dark where nothing could be seen. This was not an ordinary night sky. It was darker than night itself, because even stars had not yet been born. There was no sparkle, no faint horizon, just a thick, cosmic shadow stretching without end. Darkness was the canvas upon which the universe would one day paint its first colors. What makes this stage fascinating is that light was already hidden in the ingredients of the cosmos. Energy was there, particles were there, but the universe was too dense, too hot for light to escape. It was trapped, bouncing endlessly, unable to break free, like a voice muffled before it finds its song. We know this not from imagination alone, but from the faint traces still recorded in the cosmic background radiation. It tells us that before the glow there was confinement. And when freedom finally came, the first light was not bright like a bulb, but soft and stretching everywhere. Darkness had to exist first because contrast makes light meaningful. Just as silence makes music sweeter, the deep cosmic night gave birth to a dawn unlike any other. The secret of nothingness. One of the strangest ideas in science is that the universe may have come from nothing. Not a nothing like an empty room, but a nothing where even space, time, and emptiness did not yet exist. How can something so vast be born out of absence? That question sits at the very heart of cosmology. Physicists suggest that the laws of quantum mechanics allowed fluctuations in that nothingness, tiny flickers that grew into something more. To the human mind, it sounds impossible. And yet without those flickers, we would not be here to wonder. Out of the invisible void came the first trembling of reality. This idea unsettles and comforts at the same time. Unsettles because we like to believe beginnings must have a cause. Comforts because it suggests creation is woven into the very nature of existence. Even emptiness is not truly empty. It carries the seeds of possibility. Think of a still pond before a stone falls in. The water seems flat and calm, yet one small touch sends ripples across its surface. Nothingness may have been that kind of pond, waiting for its first disturbance. The ripple that would become galaxies, stars, and eventually you listening to this now. And so, the universe began not with a grand stage prepared in advance, but with the most fragile of whispers in a place where there was nothing to whisper at all. The birth of energy. In the earliest fraction of a second before matter could take form, there was only energy. Pure, radiant, formless energy filling the young universe. It is strange to imagine a world without things, only the invisible pulse of power moving everywhere at once. This energy was the seedbed of all that would come. Energy is the universal painter. With it, particles could appear, and with particles the possibility of stars, planets, and eventually life. At that beginning, the energy was not gentle, but overwhelming, so dense it could not be touched or seen in the way we know today. It was a fire before fire. What fascinates scientists is how this energy cooled. In its cooling, it allowed building blocks to crystallize out of chaos. Like molten lava hardening into stone, the intense blaze softened, giving rise to something more stable. That cooling was the first great act of balance. We know energy never disappears. It only changes form. The heat of that moment did not vanish. It spread, stretched, diluted, until it became the cosmic microwave background we still detect. That faint afterglow is the signature of the birth of energy. And even now, the stars overhead burn with the same principle. They are echoes of that first radiance, small reminders that the universe began with fire that never fully went out. The very first particle. Once energy cooled enough, the first particles blinked into being. Tiny, almost unimaginable points of matter that would one day give rise to galaxies. We call them quarks, electrons, neutrinos, names that sound abstract, but they were the pioneers of reality. These particles were so small and short-lived that the universe looked like a bubbling soup. They appeared, vanished, collided, and reappeared in an endless churn. It was a restless sea, yet in that restlessness patterns began to form. The quarks paired and grouped, creating protons and neutrons, which are the foundation of atoms. Out of nothing but invisible flickers, the pillars of matter emerged. It is astonishing to think that everything you can touch today began as tiny gatherings in that early swirl. Even the particles that barely interact with anything, like neutrinos, were there, streaming through space, countless in number, still flying silently through you right now. They are messengers from the very first instant, still traveling without stopping. The first particle was not just a thing, it was a doorway. Through it, the universe gained its first hint of form, the first whisper that reality could take shape instead of dissolving back into chaos. A soup of tiny sparks. In those first seconds, the universe was not a clean structure. It was a hot, glowing soup of particles and radiation mixed together. Think of a pot of water boiling so hard that bubbles rise and burst without pause. That was the early cosmos, except with quarks and photons instead of steam. The beauty of this chaos was that out of it order slowly emerged. At first, the density was too great for anything stable, but with each breath of expansion, the soup cooled just enough to let particles stick together a little longer, forming the earliest nuclei. It was a delicate recipe. Too hot, and everything flew apart. Too cold, too quickly, and there would not be enough matter to build stars. Yet somehow, the balance was just right. Hydrogen and helium were born out of that perfect timing. Imagine the entire universe as one vast cauldron, cooking the ingredients that would one day become oceans, mountains, and even your heartbeat. That soup carried within it the future of galaxies, but at the time, it was only glowing mist. The soup of sparks reminds us that creation is rarely neat. It begins messy, boiling, unsettled. And yet out of that mess, something astonishing finds its way into being. Time opening its first second. One of the strangest facts about the beginning is that time itself began then. There was no before the universe, because time did not yet exist. The first second was not just a number on a clock. It was the invention of the clock itself. In that first second, unimaginable things happened. Energy turned into particles, forces separated. The universe expanded faster than light. That single heartbeat of time carried more drama than all of human history. It is almost poetic that we measure everything against seconds, minutes, and years, yet those units were born out of this very moment. Time flowed because the universe expanded. Without expansion, there would be no rhythm to mark. Even now, the way we live, with days, seasons, lifetimes, is tied to that original unfolding. When we glance at a watch or notice the sun sinking, we are following a pattern that began at the very birth of reality. The first second is like the first word in a story. Without it, there is nothing to follow. With it, an entire universe of sentences and chapters can unfold. Space stretching wider than thought. At the same time that time was born, space itself stretched open. This stretching is called inflation, and it was not slow. It was faster than anything we can imagine. In an instant, something smaller than an atom expanded beyond comprehension. What makes this so remarkable is that space was not stretching into something. It was creating the stage itself. There was no empty container waiting to be filled. The container was born at the same moment as what filled it. As it expanded, tiny fluctuations were stretched with it. These small ripples in the fabric of space later became galaxies and clusters. It is humbling to know that the largest structures in the universe began as microscopic tremors. Even today, space is still stretching. Galaxies drift farther apart, and the fabric of the cosmos grows thinner, like dough being rolled across an endless table. Every night, sky you see is shaped by this silent expansion. Space stretching wider than thought is not just a scientific fact, it is also an invitation to wonder, to realize that what feels infinite to us began from something so small it almost could not be called anything at all. The Big Bang, not as an explosion. When people hear the phrase Big Bang, they often picture fireworks bursting into space. But it was not an explosion in the usual sense. There was no outside, no empty room where it happened. It was expansion from within, the stretching of space itself. Think of it more like a balloon inflating. Not air rushing into an existing room, but the very surface of the balloon growing larger in every direction at once. The Big Bang was quieter than an explosion, yet infinitely more powerful. This difference matters because explosions are destructive, but the Big Bang was creative. It built, it unfolded, it spread out gently at first, and then wildly fast. It was a birth, not a breaking. That is why scientists use expansion as the truer image. Even today, the expansion continues. Galaxies drift farther apart, not because they are flying through space, but because space itself is swelling. This means the Big Bang is not only something that happened, it is something still happening. It changes the way we think about beginnings. Instead of a blast that ended, we live inside an unfolding story, still stretching outward with every moment we breathe. A silent expansion in every direction. What makes the Big Bang remarkable is that it happened everywhere at once. There was no single center pushing outward. Every point was the center, every direction stretched. It was a quiet swelling of the fabric of reality itself. This silence is hard to imagine because we connect power with noise, but in the emptiness of early space there was no air to carry sound. The expansion was voiceless yet vast beyond measure. Scientists call the earliest phase inflation. In a fraction of a second, the universe expanded unimaginably. Distances that would take light billions of years to cross today grew from subatomic scales in an instant. This silent rush is almost beyond words, and yet, within that expansion, tiny wrinkles appeared. Fluctuations in density, so small they seemed insignificant at the time, but stretched across space, they became the seeds of galaxies and stars. The silent expansion carried the blueprint of everything to come. So when you look at the sky tonight, you are gazing at a pattern born out of silence. The hush of the beginning is still written in the spread of galaxies above your head, gravity weaving its invisible net. As the universe expanded, forces began to separate and take their roles. One of the most important was gravity, the quiet sculptor of creation. Though invisible, gravity became the thread that wove matter into shape. At first, particles were scattered randomly, drifting in the sea of radiation. But gravity gently pulled them together, like a net gathering fish in deep waters. Small clumps became larger clumps, each pull making the next pull stronger. Without gravity, the universe would have remained a thin mist forever. No stars, no galaxies, no planets, just endless dust drifting apart. But gravity gave the cosmos bones, a structure to grow upon. It is easy to forget how patient gravity is. Unlike explosions or lightning, it works slowly, quietly, but relentlessly. Over billions of years it shaped clusters, spirals and spheres, each guided by its silent hand. And it continues even now. Every orbit, every falling apple, every star circling in a galaxy is proof of that ancient net still holding the universe together. Light fighting through dense fog. In the beginning, light was not free. The universe was so dense with particles that photons, the carriers of light, could not travel. They bounced endlessly, trapped in a fog thicker than any mist we know. Imagine being inside a room filled with smoke so heavy you cannot see even your hand. That was the early universe. Energy was there, light was there, but it could not escape. The fog held everything captive. As the universe expanded and cooled, the fog began to thin. Slowly, atoms formed, capturing electrons that once scattered freely. With this new stability, light found its chance. It could finally slip through the spaces between matter. When that happened, the universe lit up. Not with spotlights or sudden beams, but with a gentle glow spreading everywhere at once. This was the first dawn, the release of light after hundreds of thousands of years of struggle. The light from that moment has never left us. It still glows faintly, stretched by time into microwaves, whispering across the cosmos as the background radiation scientists can measure today. The first 3 minutes of everything. The earliest minutes were unlike any other time in history. In those brief moments, the foundation of the universe was laid. Temperatures were unimaginably high, reactions rapid and relentless. During those first 3 minutes, protons and neutrons fused to form the first atomic nuclei. Hydrogen, helium, and traces of lithium were created in this fiery crucible. These simple elements became the raw material for stars and galaxies. It is astonishing to realize that in less time than it takes to boil water, the universe created most of the matter that exists around us today. 3 minutes wrote the script for billions of years to follow. After that, the universe cooled enough to stop the process. Fusion would wait until stars ignited millions of years later. But the basic recipe was already complete. The balance of hydrogen and helium was set, unchanging across time. So much depended on that fleeting window. If the mix had been different, stars might never have formed, or life as we know it might have been impossible. The first 3 minutes were not just fast, they were decisive. Matter deciding to stay or vanish. In the very early universe, matter and antimatter were created in equal amounts. But when they met, they destroyed each other in brilliant flashes of energy. For a moment, it seemed the universe might cancel itself out before it truly began. And yet, something unexpected happened. For reasons we still do not fully understand, a tiny imbalance appeared. For every billion pairs of matter and antimatter that vanished, one lonely particle of matter remained. That small leftover made all the difference. It is humbling to think that everything you see, every star, every mountain, every breath you take, exists because of that imbalance. If the symmetry had been perfect, there would be no matter left at all. Only empty radiation filling endless darkness. Scientists still search for the reason behind this cosmic preference. Why did matter survive? Why was the universe tilted slightly towards something instead of nothing? The answer may be hidden in the laws of physics we do not yet grasp, but what we do know is this: the universe exists because matter decided to stay, ever so slightly stronger than its shadow twin. That tiny victory became the foundation of all creation, the cool breath of the newborn cosmos. As the universe expanded, it began to cool. Temperatures dropped from trillions of degrees to millions, then to thousands. This cooling was not a collapse, but a gentle breath, the cosmos exhaling after its furious birth. Cooling allowed particles to slow down just enough to form stable bonds. Without this, matter would have remained wild, chaotic, unable to combine. The universe needed calmness to allow structure to grow. This cooling also set the stage for atoms. Once the frenzy settled, protons could capture electrons, giving birth to the simplest atoms of hydrogen and helium. These were like the alphabet of creation, the letters from which all words of matter would later be written. The beauty of this moment is that cooling gave time room to stretch. Stars and galaxies could not have formed in chaos, but only in the slowed rhythm of a cooling universe. Silence returned, but now it was filled with possibility. Even today, the universe still cools as it expands. The cosmic background radiation we measure is only a few degrees above absolute zero, a faint memory of the fiery beginning slowly fading into eternal calm. Hydrogen, the universe's first child. The very first stable atom was hydrogen. One proton, one electron bound together in the simplest embrace. It may seem ordinary, but hydrogen became the cornerstone of everything. Hydrogen filled the universe like a gentle mist, invisible, countless, drifting across space. In time, gravity would gather it into clouds and clouds into stars. Hydrogen was not just a gas, it was the raw fabric from which light itself would be born. Stars live by burning hydrogen. In their cores, hydrogen fuses to form helium, releasing energy that shines as starlight. Every sunrise you see is powered by this ancient process. The story of hydrogen is written across every star-filled sky. What is astonishing is how much of the universe is still hydrogen. Even now, billions of years later, 3/4 of all matter is made of it. The simplest atom proved to be the most enduring. And without hydrogen, there would be no stars, no galaxies, no chemistry, no life. It was the first child of the cosmos, and it still carries the flame of creation in every flicker of light you see above. Helium arriving beside it. Close behind hydrogen came helium, slightly more complex, with 2 protons and 2 neutrons bound in its nucleus. If hydrogen was the firstborn, helium was its quiet companion. Together, they made up almost all the newborn universe. Helium may seem simple, but it carries elegance. Its stability makes it gentle, unwilling to react like other elements. It floated through the early cosmos as a noble presence, watching quietly as hydrogen took center stage. But helium had its role. In stars, when hydrogen fuses, helium is the product, and later, when stars grow old, helium itself fuses into heavier elements. Without helium, the chain of creation could not continue. Even today, when you hold a helium balloon, you are holding a piece of the universe's first breath. Something ancient, born in the earliest moments, still drifting gently in your hands. Helium reminds us that not all power is loud. Some elements, like some people, shape the world quietly simply by being steady, stable, and enduring. A cosmic recipe still unchanged today. The mix of hydrogen and helium set in those first few minutes has never changed. About 75% hydrogen, 25% helium. That ratio, decided long ago, still fills the universe today. This recipe became the foundation of chemistry, astronomy, and life. Every star was born from it, every galaxy built upon it. The universe has been cooking with the same 2 ingredients ever since, only adding new flavors as stars forged heavier elements in their fiery hearts. What is beautiful is how universal this recipe is. Look anywhere in the cosmos and you will find the same proportions. From the edge of distant galaxies to the stars above your home, the mix is unchanged. It feels almost like the universe wrote itself a simple rule. Begin with hydrogen and helium, and from there let creativity take its course. And out of that simple start, endless diversity unfolded. Planets, oceans, forests, and minds that wonder about it all. So tonight, as you breathe, remember that the air in your lungs is touched by that first recipe. The story of the universe's beginning is still inside you, unaltered since the dawn of time. The fog lifting after 80,000 years. For hundreds of thousands of years, the universe was wrapped in a dense fog. Particles and light tangled together so tightly that nothing could shine through. But around 380,000 years after the beginning, something remarkable happened. The fog began to lift. This was the moment atoms settled into stable forms. Electrons, once bouncing freely, were captured by protons forming hydrogen atoms. Suddenly space became transparent. It no longer had to struggle. It could travel freely for the first time. The transformation was quiet but profound. In an instant, the universe changed from a glowing soup to a clear expanse. It was as though the cosmos had opened its eyes. That first light still travels across the universe today. We know it as the cosmic microwave background, a faint glow stretched by time. It is the oldest light we can ever see, the universe's childhood photograph still shining above us. The lifting of the fog was not just an event, it was a doorway. It allowed light to carry the memory of the beginning, a memory we can still read in the sky with our instruments today. Light finally finding freedom. Once the fog lifted, light streamed freely across space. Imagine the joy of a voice finally being heard after ages of silence. Photons, the tiny messengers of light, began their endless journey. This was the universe's first sunrise, not from a star, but from the cosmos itself. A soft glow spread everywhere, not from one point, but from all directions at once. It was gentle, universal, and eternal. For us, this light is more than a relic. It carries information. By studying its faint ripples, scientists can learn about the density, shape, and age of the universe. It is like reading wrinkles on an ancient face, each line telling a story. Even though it is faint, this light has never faded away completely. It still bathes the universe in a soft microwave glow. Everywhere you are, right now, this ancient light passes through you silently. Light's freedom reminds us that liberation is not sudden brightness, but the quiet ability to travel, to move, to carry memory across unimaginable distances. The glow we still see, the cosmic background, the cosmic microwave background, is the most ancient light we can observe. To the human eye, it would appear as a faint, uniform glow, almost unnoticeable, but with sensitive instruments, it becomes a map of the early universe. This glow is not smooth. It carries tiny variations, slight differences in temperature and density. These variations may look small, but they are the fingerprints of creation. They shaped where galaxies would form, where matter would gather, and where voids would remain empty. It is extraordinary that the universe left behind such a record, a frozen echo of its first steps. Without it, we would be blind to the details of how the cosmos grew. The glow is also evidence that the Big Bang truly happened. No other explanation fits the precision and spread of this light. It is the aftertaste of the universe's birth, stretched thin but still present. So when scientists point radio telescopes into the sky, they are not just looking at stars, they are listening to the faint hum of creation itself. Tiny ripples shaping galaxies. Those small fluctuations in the cosmic background may seem insignificant. Tiny ripples, almost invisible in the glow. But without them, the universe would be flat and empty. Each ripple was a slight difference in density, a place where matter was a little thicker, a little more gathered. Over time, gravity pulled more matter into these ripples, turning them into seeds of galaxies and clusters. It is astonishing to realize that the beauty of spiral galaxies and the grand arcs of clusters was shaped by imperfections. The universe was not perfectly smooth, and that imperfection became its strength. Even in our own Milky Way, the stars we see trace their origin back to one of those ripples. Without them, there would have been no clumping, no structure, no light in the night sky. The lesson the cosmos whispers here is gentle. Perfection is empty, but small irregularities can give birth to unimaginable beauty. Dark matter joining the dance. Alongside ordinary matter, another ingredient was already shaping the universe. Dark matter, unseen, mysterious, yet essential. We cannot see it, but we know it must be there because gravity reveals its pull. Dark matter gathered around those first ripples, deepening the seeds where galaxies would form. It created invisible scaffolding, a hidden framework on which visible matter could settle. Without it, the cosmos would not have built stars so quickly. What is remarkable is that dark matter does not shine, reflect, or interact with light. It passes through us silently as if it belongs to another layer of reality. Yet without it, we would not exist. Scientists estimate that dark matter makes up most of the universe's matter. What we see, stars, planets, people, is only a small fraction. The real structure lies in the unseen. Dark matter's presence reminds us that the most powerful forces in life are not always visible. Sometimes what shapes everything is hidden, working quietly behind the scenes, just as it did at the beginning of time, an invisible partner guiding the visible. The beauty of the early cosmos is that what we could not see was just as important as what we could. Dark matter, silent and unseen, gathered into vast webs that ordinary matter followed. Like a skeleton hidden beneath the skin, it shaped the outlines of the universe. Galaxies formed where dark matter clumped most strongly. Without this invisible partner, stars would have scattered too thinly to ever create structure. It was as though the unseen hand sketched the lines and visible matter painted the colors. Scientists map this hidden framework not by sight, but by the way galaxies move and bend light. The invisible reveals itself through its influence, a reminder that presence does not always require visibility. Even today, this partner still guides us. The Milky Way itself sits in a dark matter halo, an unseen cocoon that holds it together. Everything we know is suspended in this hidden embrace. The cosmos reminds us here of a simple truth. What you cannot see may still be holding everything in place. The birth of the first stars. After long ages of darkness, the universe witnessed its first light from stars. Giant clouds of hydrogen collapsed under gravity, growing hotter until nuclear fire ignited. In that moment, darkness was pierced by brilliance. These first stars were massive, far larger than our sun. They burned quickly, lived briefly, and died violently. Yet in their short lives, they gave the cosmos its first true illumination. The arrival of starlight was more than beauty. It transformed the universe. The radiation from these stars cleared away the last traces of cosmic fog, making space transparent forever. Without them, galaxies would not have taken form. Their light and gravity pulled matter together, shaping islands of stars that grew into majestic spirals and clusters. The first stars remind us that beginnings often start in darkness, but from that darkness the first flickers of light can change everything. Darkness pierced by starlight. When the first stars ignited, the universe changed forever. What had been endless night became dotted with brilliance. For the first time, light traveled across vast distances to shine in the dark. Imagine standing in a desert where no lamps, no moon, no stars exist. Then suddenly, a single flame flickers, followed by thousands more. That was the dawn of starlight across the cosmos. The light carried more than beauty. It carried energy, reshaping the chemistry of space. It ionized hydrogen, broke apart atoms, and remade the environment for future generations of stars and galaxies. This moment is known as the era of reionization, a time when the universe transitioned from opaque to truly transparent, lit by countless newborn suns. Every star we see today is part of that legacy. Each twinkle is a descendant of the first flames that pierced the darkness, declaring that the night sky would never be empty again. The first galaxies taking shape. Stars did not remain scattered for long. Gravity gathered them into families, bound together in great clusters. These were the first galaxies, islands of light in a sea of darkness. Some were small, just loose gatherings of stars. Others grew massive, forming structures that would evolve into spirals and ellipticals. Galaxies became the architecture of the universe, the great cities of stars. What makes this moment so moving is that galaxies were not built in isolation. They formed along the threads of dark matter, connecting into a vast cosmic web stretching across space. Even the Milky Way, the galaxy we call home, traces its roots back to this time, a small star city in the making, slowly gathering strength across billions of years. The first galaxies remind us that creation does not happen in pieces but in patterns, everything connected, everything woven together across unimaginable scales, clusters gathering across space. As galaxies grew, they began to gather into clusters. groups of hundreds, sometimes thousands, held together by gravity's patient hand. These clusters became the grand structures of the cosmos. Within them, galaxies interacted, collided, merged. Each encounter shaping new forms, new bursts of starbirth, and sometimes even central black holes. Clusters were not quiet places. They were lively arenas of cosmic drama. Between the galaxies flowed vast rivers of gas, heated to millions of degrees, glowing faintly in X-rays. These intergalactic spaces were as important as the galaxies themselves, feeding new generations of stars. Clusters, linked together across filaments of dark matter, forming superclusters, some of the largest structures the universe has ever known. Their scale is so vast that light takes hundreds of millions of years to cross them. When you look at a patch of night sky through a telescope and see hundreds of galaxies glowing together, you are looking at one of these clusters, ancient gatherings that still hold the universe in balance. Black holes rising with the galaxies. As galaxies formed, so too did black holes. Those mysterious regions where gravity is so strong that nothing, not even light, can escape. They were born from the collapse of giant stars and grew in the hearts of young galaxies. At first, they were small, but as galaxies collided and stars fed them, they swelled into supermassive black holes, some as heavy as billions of suns, anchoring the very centers of galaxies. It may sound paradoxical, but black holes helped galaxies grow. Their powerful pull stirred gas, triggered star formation, and shaped the rhythms of cosmic cities. In their silence, they were builders as much as destroyers. Even today, at the center of our own Milky Way lies a black hole called Sagittarius A. It quietly governs the motion of millions of stars around it, invisible yet essential. Black holes remind us that even the darkest mysteries can carry purpose. In the beginning, they rose not to end the story, but to deepen it. Stars dying to create heavy elements. The first stars were massive and short-lived. They burned fast, then collapsed in violent deaths called supernovae. In those explosive endings, something extraordinary happened. Heavy elements were born. Carbon, oxygen, iron, and many others were forged in the furnaces of dying stars. These elements scattered into space, mixing with hydrogen and helium, enriching the cosmic recipe. Without these deaths, there would be no rocky planets, no water, no living bodies. The universe needed endings in order to make beginnings. Every breath you take carries atoms once formed in the heart of a star long ago. Scientists call this process nucleosynthesis, but it is also poetry. The transformation of starlight into matter, the recycling of fire into form, life itself is made from these ashes. So the death of stars was never a tragedy. It was the universe planting seeds, ensuring that creation could continue on deeper and richer levels. Carbon, oxygen, iron, written into matter. The elements born from stellar deaths became the building blocks of everything familiar. Carbon formed the backbone of life's chemistry. Oxygen made water possible. Iron gave strength to planets and to blood itself. It is humbling to realize that your body is written in the language of stars. The iron in your veins once glowed in a star's core. The oxygen you breathe was forged in cosmic fire. You are, in the most literal sense, stardust. What is even more astonishing is the universality of this truth. Every creature, every plant, every ocean and mountain carries the same heritage. The cosmos does not play favorites. It writes its story in every form of matter. Scientists trace this process across galaxies. Everywhere they look, they see the same pattern. Stars live, die, and enrich the universe with elements. It is a cycle repeated endlessly across time. The next time you look at the night sky, remember that it is not just above you. It is within you, shining quietly in every breath and heartbeat, the seeds of future life. When heavy elements mixed with hydrogen and helium, the universe held new possibilities. Planets could form, oceans could gather, and life could one day awaken. These were the seeds of future existence, scattered across galaxies. In nebulae, giant clouds of gas and dust. These ingredients swirled and condensed. Some regions collapsed into new stars, others into rocky worlds orbiting them. Each seed carried the potential for chemistry complex enough to dream. The beauty lies in the timing. Life could not have begun earlier. The universe had to wait for stars to live and die, to scatter their gifts before planets could grow fertile. Even patience itself seems written into the cosmos. We often think of life as fragile, but in truth, it was the natural flowering of conditions the universe carefully prepared. The seeds were everywhere, waiting for the right soil. And now, billions of years later, those seeds bloom not only on Earth, but perhaps in countless places we have yet to discover. Galaxies colliding to grow larger. Galaxies were not static. They drifted, met, and collided in slow-motion dances lasting millions of years. Far from destroying each other, these collisions often created new bursts of stars. When two galaxies merged, their stars mostly passed without hitting, but their gas clouds smashed together, compressing into brilliant new star nurseries. In the aftermath, larger and more complex galaxies were born. Even our Milky Way is the result of many such mergers. Smaller galaxies fed into it, leaving behind streams of stars that still orbit today. And in the far future, the Milky Way will merge with the Andromeda Galaxy in a spectacular cosmic union. These collisions shape the architecture of the cosmos. Without them, galaxies would remain small and simple. With them, vast spirals and ellipticals grew, filled with billions of stars. The universe shows us here that even encounters that look chaotic can create beauty. Out of collisions, harmony emerged, grander than what existed before. Spiral arms unfolding like flowers. As galaxies matured, some grew into beautiful spirals, their arms stretched outward, curving gracefully, filled with billions of stars. They looked almost like flowers opening in slow motion, petals of light blooming across space. These arms were not solid structures, but waves of density moving through the galaxy. As they passed, they compressed gas and dust, sparking new generations of stars. The spiral arms became cosmic nurseries, always renewing themselves. Our own Milky Way is such a spiral. Each arm carries rivers of stars, nebulae and clusters, winding around the galactic center. From within, it looks like a river of light flowing across the night sky. It is humbling. To think that the beauty we see in spiral galaxies is not decoration but function. Their graceful curves are the engines of starbirth, the rhythms of cosmic growth. The universe paints with elegance. Even the mechanics of gravity and gas take on shapes that stir wonder in the human heart. The Milky Way finding its place. Our home galaxy, the Milky Way, is just one among billions. Yet it carries its own story, shaped by collisions, mergers, and quiet starbirth. It is neither the largest nor the smallest, but it is vast enough to cradle hundreds of billions of stars. The Milky Way stretches about 100,000 light-years across. Within it are spiral arms, a central bar, and countless clusters. It is a city of stars, each moving in quiet orbits guided by gravity. It also belongs to a larger family. Alongside the Andromeda Galaxy and dozens of smaller companions, It forms what we call the local group, a small neighborhood within the endless universe. Though it feels immense to us, the Milky Way is only one thread in the great cosmic web. Yet for us, it is everything: our cradle, our stage, our shelter under the stars. The Milky Way's story is a reminder that home does not need to be the largest. It only needs to be where your story is written. Billions of stars lighting its heart. Within the Milky Way lie hundreds of billions of stars. Some are young and blue, burning hot and fast. Others are old and red, slowly fading after long lives. Together they form the living heart of the galaxy. Most stars cluster near the spiral arms, but at the center lies something even denser, a crowded region of countless suns glowing with intensity. Around them, gas and dust swirl in luminous clouds lit up by their brilliance. Among these stars are many like our Sun, with planets quietly orbiting them. Others are giants, thousands of times larger, burning brightly before their inevitable end. The diversity is staggering. What is moving is the thought that each of these stars could host its own stories. Worlds we will never see, skies we will never walk under, yet all existing within our shared galaxy. The billions of stars remind us that the night sky we see is only a fragment. The true brilliance of the Milky Way lies in what we cannot see with our eyes alone, a small star called the Sun. Among the billions of stars in the Milky Way, one small yellow star became special to us. Our Sun. It is not the largest or the brightest, but for Earth, it is everything. The Sun formed about 4.6 billion years ago from a cloud of gas and dust. Gravity pulled material together, igniting nuclear fusion at its core. From that moment on, it has burned steadily, giving warmth and light to its surrounding planets. What makes the Sun remarkable is its balance. Not too hot, not too unstable, steady enough to shine for billions of years without flickering out. It is this stability that made life on Earth possible. Around it, planets formed, each with its own character. Some barren, some gas giants, and one small blue world covered in oceans. The Sun became the heart of our solar family. And though it is just one star among billions, it shows how even something ordinary can hold extraordinary importance when it becomes the center of a living world. Planets gathering around it. As the Sun ignited, the leftover gas and dust around it began to swirl. Tiny grains collided, sticking together, growing into rocks, then worlds. This was the birth of the planets. Closer to the Sun, rocky planets formed: Mercury, Venus, Earth, and Mars. Farther out, gas giants gathered: Jupiter and Saturn, followed by Uranus and Neptune. Together they became the solar system we know today. Each planet carries its own story. Some with thick clouds, others with icy rings, and one with oceans and life. All born from the same cloud, yet each unique in its unfolding. The process was not simple. Planets collided, moons were captured, and debris was scattered. It was a chaotic ballet, but out of it came stability. A family of worlds circling in harmony around their star. When you look at the night sky, remember that Earth is not alone. It is one member of this grand family, all bound together by the Sun's steady light. Earth forming in molten fire. Our planet began as a ball of molten rock, glowing red, its surface too hot for life or oceans. Gravity pulled together dust and stone from the young solar system until a fiery world took shape. In those early days, Earth was battered by countless collisions. Asteroids and comets struck, adding new material, heating the surface again and again. It was violent, yet necessary. shaping the foundation of the world we now walk on. The young Earth spun quickly, its atmosphere filled with poisonous gases. Nothing green, nothing blue, only a restless surface cracking and reforming with lava flows. It was a planet in the making, still finding its balance. Deep inside, heavy elements like iron sank to the core, while lighter materials floated upward. This layering gave Earth its magnetic field, the shield that would later protect life from harmful radiation. Though hostile at the start, the fiery Earth was not a mistake. It was the crucible where stability and protection slowly formed, preparing the ground for everything that would follow. Water arriving from cosmic messengers. Earth at first was dry and barren, but water arrived from beyond, carried by comets and asteroids rich in ice. Each impact delivered droplets of the oceans we now know. It is humbling to realize that the water in your glass may have begun its journey billions of years ago, frozen inside a comet wandering the solar system. When those icy bodies struck Earth, they melted, filling craters and lowlands. Slowly, over millions of years, seas gathered, rain fell, rivers carved paths. The once fiery surface cooled under the embrace of water, transforming into a blue planet. This gift from the cosmos did more than change the landscape. Water became the cradle of life, the medium where chemistry could dance into complexity. Without it, Earth would have remained a silent rock. Every drop of rain, every wave on the ocean is a reminder of those ancient messengers. The universe itself poured life's first ingredient onto our world, life preparing its quiet entrance. With oceans spread across Earth, the stage was set for life. In the warm, shallow seas, chemistry began to weave its first patterns. Molecules combined, broke apart, and combined again. These early steps were fragile, almost invisible. Tiny strands of molecules learned to copy themselves, forming the earliest ancestors of DNA. Out of simplicity came the power to grow and adapt. For millions of years, this process remained unseen. No plants, no animals, only microscopic life learning to thrive in the oceans. Yet these invisible beginnings carried the potential for forests, birds, and human thought. It is moving to realize that life did not arrive suddenly. It crept in gently like dawn spreading across the sky. Each small step prepared the way for greater complexity. Life's entrance reminds us that patience is the rhythm of the universe. Great things rarely rush. They unfold slowly, waiting for the right moment to bloom, the sky filled with ancient starlight. As life stirred in Earth's oceans, the night sky above told another story. Starlight, born billions of years earlier, streamed across space to shine down on the young planet. Every point of light was a sun in its own right, many larger and brighter than ours. Together, they formed a ceiling of wonder, a backdrop for the silent drama unfolding on Earth. That starlight carried more than beauty. It brought energy, ultraviolet rays, shaping chemistry, guiding the growth of molecules in unexpected ways. Even distant stars had a role in life's unfolding. Looking back, we see the sky not as decoration, but as a participant in creation. The same light that warmed oceans and drove reactions still shines on us today, linking past to present. The night sky above Earth became the first book of knowledge. Written not in words, but in stars, a story stretching back to the beginning of time. The universe still stretching today. Even as Earth cooled and life began, the universe itself continued to expand. Galaxies drifted farther apart. Carried by the silent stretching of space, the Big Bang was not finished, and it still echoes in every direction. This expansion means the universe is larger now than it was a moment ago. It is an ongoing creation, never fixed, always in motion. What fascinates scientists is that the expansion is not slowing down. Instead, it accelerates, driven by something mysterious we call dark energy. A force we cannot see, but one that pushes galaxies apart faster and faster. The night sky looks calm, but beneath it lies this restless growth. Every second, the distances between galaxies increase, as though the fabric of space is breathing outward. To lie under the stars and know this is to feel wonder. The universe is not a finished painting, it is still being painted, and we are inside the canvas. Galaxies drifting farther apart. When we look deep into the night sky, every galaxy is moving, not toward us, but away. The farther a galaxy is, the faster it recedes, carried by the expansion of space itself. This discovery, first made by Edwin Hubble in the 20th century, transformed our understanding. The redshift of galaxies showed us that the universe is not static, but restless, forever unfolding outward. It is not galaxies racing through space like cars down a road. Instead, the road itself is stretching, carrying galaxies with it. Space expands, and everything rides along silently. Over billions of years, this drift will continue. Galaxies will grow farther and farther apart, their light stretched into longer and longer wavelengths until only nearby clusters remain visible. It is strange to think that the night sky we see now is temporary. Future observers may see fewer stars, fewer galaxies. But for us, the sky is still rich, still filled with countless distant lights. Dark energy pushing them faster. Even more mysterious than expansion is acceleration. In the late 1990s, astronomers discovered that galaxies are not only drifting apart, they are speeding up. Some hidden force is pushing them faster, and we call it dark energy. Dark energy makes up nearly 70% of the universe, yet we do not know what it truly is. It does not shine, it does not pull like gravity. It simply pushes, stretching space at an ever-increasing pace. This means the future of the cosmos will be shaped by something we cannot see. Galaxies will drift away so quickly that one day their light may never reach us. The universe will appear lonelier even as it grows larger. It is humbling that the force controlling the fate of everything is still a mystery. Scientists build models, run experiments, but dark energy remains silent. Sometimes the unknown is not just in the past, it is in the future, waiting for us to discover its name. The cosmic web revealed. When scientists map galaxies across the universe, they do not appear randomly scattered. Instead, they trace vast filaments, weaving into a grand structure we call the cosmic web. This web stretches for billions of light years. Galaxies cluster along its threads like dew on spider silk, while between them lie enormous voids of near emptiness. Dark matter forms the hidden framework of this web. Ordinary galaxies simply illuminate its structure like lanterns hanging on invisible lines. The cosmic web shows us that the universe is not just a collection of objects, but an interconnected whole, a vast, delicate network linking everything across unimaginable distances. To look at the web is to glimpse the handwriting of creation. Patterns that echo on every scale, from tiny atoms to galaxy clusters, reminding us that order lies beneath apparent chaos. Threads of galaxies like lace. The cosmic web is not heavy or dense, it is delicate, almost lace-like. When seen in computer simulations, its threads glow faintly, curving and connecting in graceful patterns. These threads are highways of matter. Along them, galaxies form, gas flows and clusters gather. The spaces between remain quiet, empty voids, contrasting with the richness of the filaments. From a distance, the entire universe looks like embroidery. Vast lines of light stitched across darkness, each knot a galaxy cluster, each thread a path of unseen dark matter. It is a reminder that beauty is not only in small things. Even at the largest scales, the universe arranges itself in ways that stir awe, shapes that feel almost artistic. Every galaxy we see tonight, including our own, belongs to one of these threads. We are part of the lace. One star among billions decorating the fabric of the cosmos. Endless space beyond what we see. Even with our most powerful telescopes, we can only glimpse part of the universe. Beyond that lies more, perhaps infinitely more, stretching past the limits of light itself. The observable universe is like a bubble, 93 billion light-years across. But outside this bubble, space continues. Galaxies we will never see, light that will never reach us, mysteries forever hidden from our eyes. This horizon is not a wall, but a limit of time. Light has only had so long to travel since the beginning. The farther we look, the younger the universe appears. Beyond that, the story continues unmain. It is humbling to accept that we may never see the full picture. Yet perhaps that is the point. The universe leaves us with mystery, so wonder never ends. When you gaze into the night sky, remember what you see is only a fraction. Beyond it lies endless space, a silence so vast it may never be measured. Echoes of the first second remain. Though billions of years have passed, the universe still carries traces of its first heartbeat. Those early instants left ripples and signatures that scientists can detect even today. The cosmic microwave background is one such echo. But there are others too. Patterns in how galaxies cluster, the faint tremors in gravitational waves, the very balance of matter itself. It is astonishing that the first second, so fleeting, left fingerprints strong enough to endure across eternity. The universe remembers its beginning, even if only in whispers. Every measurement we make, of light, of expansion, of background radiation, is like listening for those echoes. Each one gives us a clue, a fragment of the story written in the silence of that first instant. The echoes remind us that nothing truly vanishes. Even the earliest moments are still here with us, stitched quietly into the fabric of everything that followed. The background hum of creation. Beyond the visible light, beyond even the faint microwave glow, there is a deeper hum. The universe resonates with vibrations left over from its birth, a quiet music too low for human ears. Scientists believe gravitational waves, tiny ripples in space-time itself, still carry this hum. If we could listen closely enough, we might hear the universe's first rhythm, its opening note. This background hum is not loud or dramatic. It is subtle, like the sound of wind in the distance, or the faint ringing of a bell long after it has been struck. Detecting it is one of the great challenges of modern science. Sensitive instruments stretch across continents, waiting for the faint tremble of space-time to pass through them. If we succeed, we may hear not just the beginning, but the ongoing song of the cosmos. A reminder that creation itself still reverberates long after the first moment has passed. Questions that never end. For every answer science uncovers, new questions rise. Where did the laws of physics come from? Why does the universe exist at all? What lies beyond what we can see? These questions are not signs of failure. They are signs of depth. The universe is not a puzzle to be solved once, but a mystery that deepens the more we explore. Ancient cultures asked these same questions in myth and story. Today we ask them with telescopes and equations. Yet the wonder behind them remains the same. Even if we never know the final answers, the act of asking connects us. It makes us part of the story, participants in the same mystery that shaped the stars. Perhaps the universe is designed to keep us questioning, to remind us that certainty is small but curiosity is infinite. Was there something before the beginning? This is one of the most haunting questions. If time itself began with the Big Bang, can we even speak of before? Or does the concept lose meaning, like asking what is north of the North Pole? Some scientists imagine cycles, universes born, expanding, collapsing, and being reborn again. Others suggest quantum fluctuations gave rise to our cosmos out of a timeless sea of possibilities. Still others believe our universe may be one bubble among many, each with its own laws, each expanding in its own way. In that view, our beginning is only one chapter in an endless library. The truth is, we may never know. The veil of the beginning is thick, hiding whatever lies beyond it. Yet the question itself is beautiful, a doorway into wonder. Even in silence, the possibility of before invites us to dream. Perhaps beginnings are never singular, but woven into cycles beyond imagination. The possibility of many universes, from the mystery of before comes the idea of the multiverse. Countless universes, each with different rules, different constants, different stories. We may be only one in an endless ocean of creation. Some theories suggest new universes bud off like bubbles in boiling water. Others picture infinite space with regions so distant they follow their own physics entirely. If true, it would mean our universe is not unique. Yet within that vastness, our place remains special. The one corner where conditions gave rise to us, to Earth, to life. The multiverse is not proven. It is an idea at the edge of science, part theory, part philosophy. But it reminds us that our imagination must be as wide as the cosmos itself. Whether or not many universes exist, the thought itself humbles us. It shows how small we are and how vast reality may truly be. A cycle of births and endings. The universe is not a straight line, it is a rhythm, a breathing pattern of births and endings, beginnings and dissolutions. Stars are born, shine brightly, then collapse, only to give birth to new stars from their ashes. Galaxies, too, merge, break apart and reform. Even black holes, though they seem eternal, may one day evaporate, returning their energy to space. Every ending carries a hidden beginning. Some scientists imagine the universe itself may follow such a rhythm, expanding, collapsing, and expanding again. A cycle stretching beyond comprehension. Whether true or not, the pattern is visible all around us, in nature, in life, in the cosmos. Growth, decline, renewal, each step part of a larger harmony. The cycle of births and endings whispers that nothing is wasted. Every light, every shadow, every silence belongs to the music of creation. Time flowing like an unseen river. We often picture time as numbers on a clock, but in the universe, time flows more like a river, smooth, relentless, carrying everything forward. From the first second to now, time has never paused. Stars live and die, galaxies drift, life rises and falls, all swept along by this current. Yet time is not the same everywhere. Near massive objects it slows. Far in deep space it stretches. Einstein showed us that time bends with gravity, turning the river into something flexible, alive. It is haunting to think that your heartbeat flows differently from someone standing near a black hole. The universe carries many rivers of time, each moving at its own pace. But all rivers begin at the same source, the birth of the cosmos. Time itself was born there, and its waters still carry us onward without end. Space holding secrets in silence. The emptiness between stars looks quiet, but space is never truly empty. It holds secrets, faint radiation, drifting particles, dark matter, and the memory of ancient light. Even the vacuum itself has energy, tiny fluctuations that appear and vanish endlessly. The silence of space is alive with invisible motion. Scientists explore this silence with telescopes, detectors, and equations, yet it always holds more than it reveals. For every discovery, another layer of mystery appears. What is striking is how much the silence gives us. It allows galaxies room to grow, stars space to shine, and life a stage to wonder. Without silence, there could be no symphony. Space whispers its secrets not in noise but in stillness, teaching us that quietness is not emptiness, but possibility waiting to be seen. Our place in the great unfolding, amid galaxies, stars, and endless distances, Earth may seem small, and yet it carries the rare gift of life. We are not separate from the universe, but born of its very elements. The hydrogen in our cells, the carbon in our bones, the iron in our blood, all forged in ancient stars. We are the universe reflecting on itself, asking questions about its own beginning. Our place is not at the center, but within the flow. Just one thread in the cosmic web, yet essential to the story we carry forward. Every glance at the night sky is not just looking outward, but inward. We are connected deeply to everything we see. To know this is to find both humility and wonder, small in scale yet vast in meaning because the universe chose to awaken in us. Falling asleep with the universe still expanding. As you rest tonight, the universe continues its silent work. Stars are born, galaxies drift, light travels across unimaginable distances. Expansion never stops, not even while you sleep. Each breath you take is in rhythm with a cosmos still unfolding. The story that began billions of years ago continues with you inside it. The night sky above is not a painting fixed in place. It is alive, shifting, stretching, whispering across time. Every star is part of a greater motion that carries on forever. To fall asleep under this thought is to rest in the arms of something vast and timeless. A reminder that beginnings never truly end. They only change form. And so as you close your eyes, the universe still expands, carrying you with it gently, silently into the endless unfolding of creation.